Hi there, and welcome to a secure end-to-end testing. Bit of a brown bag video. I'll be going through some slide notes. I'll be demoing the running of an end-to-end test, just to kind of show it isn't too scary. This is primarily created for the secure protect audience, but a lot of what is discussed here could be applicable to all our groups. So let's progress. So if you've ever seen MEC on a call or a department, a quality department group conversation, it always has this quote behind them, and there's a good point behind it. You know, we're all striving for a quality product. So here's a bit of an agenda on what we'll cover off. I don't want it to be death by slides, so we cover off the 6 W's. So first of all, what do we mean by end-to-end testing? So from our official documents, the strategy used to check whether your application works as expected across the entire software stack and architecture, including integration, all microservices components that are supposed to work together. I will say that to me, the end-to-end tests are more interested in a scenario than an individual low-level function, for example. So why do we end-to-end test? So we're at a bit of a higher level. There are less end-to-end tests than there would be unit tests. We are more focused on how the workflow works together and how an end user might work when using the GitLab products. Where are our end-to-end tests? So underneath the QA directory, our secure tests live under this path QA specs, features EE versus UI secure. Under the QA directory, we also have page functions, which we'll touch upon soon, and pre-populated reports that we use for secure. And where are they executed? So mostly pipelines. There are a number of pipelines. I will discuss them, but I'll cover off in a future brown bag how to debug the pipelines. Packaging QA step of merge requests. So folks have probably seen this being mentioned. It's for the most part it's a manual step unless there are changes to the QA directory. And we can execute locally against an instance. For example, GDK, an image like a nightly image, an environment such as staging. So this is useful if you want to replicate a particular test failure. So how do our tests work? So the secure tests are mostly UI driven. UI components are important for driving our workflows using Selenium Capybara. We rely on UI elements, these things, data QA selectors, so folks may or may not have seen them throughout the codes, especially the front-end code. But these are fairly important for our tests. The API, it's mostly used in the secure tests for test setup, creating a project, preparing a merge request. A bit of a high-level step through of what a secure end-to-end test might look like. So we create the project via the API. We populate with pre-populated scanner reports. The CI within this pre-populated project is mostly made up of no-ops, and I'll touch upon this later on. We typically create a merge request where the pipelines kick off, and then from that perform UI actions relating to the item under inspection. So be that the merge request widget, pipelines, dashboards, etc. So for example, here's an example of one of my tests. So this one in particular is the security dashboard spec. So at the start I have a couple of constants. Before we do anything, you log in, you use the API to create the project, create a runner. Then we push up to a branch, so this is where our secure pre-made reports are utilized. Push up to a branch, from that branch create a merge request. And then from the merge request, wait until the pipeline has passed, merge the merge request, wait until the latest pipeline has passed. I also added a label. This was for a test that I recently added. So for example, simple test, we want to show vulnerability details. So let's have an example, this first step here, which is just very simply click on the vulnerability report. So page, project menu, perform, click on vulnerability reports. That click on vulnerability reports lives under the QAE page project submenu security compliance module, which is here. So we hover over security compliance. So in that submenu, click element vulnerability report link. Vulnerability report link is specified here within the project security link HTML HAML. And this is the code that generates it. Data QA selector being the vulnerability report link. So you can kind of see that from the source code and our abstractions, how our tests drive things along. So yeah, once we click that, within the security dashboard, we expect to have the vulnerability, drill down to vulnerability details. Do we have a header? Do we have details? Is the title of vulnerability name? Do we have the correct description? And do we have the footer? So that's a bit of a step through on how the tests are put together. So yeah, as was shown previously, so for example, click on vulnerability report, which is a function within our QA page module, which has a view from the security link HAML, which contains an element vulnerability report link, and within the actual source code itself, this is a vulnerability report link, which when the page is actually built, is displayed within the source code as data QA selector vulnerability report link. So this is how our test knows, where to click and which elements to pick up, etc. So how do we run a test locally? So don't be put off by what looks like quite a hefty command line here. Basically, our main executable is one.exec bin QA. Test instance all, which is a bit of a catch-all. Our instance, which in my case, I'll demonstrate my local GDK instance, and then the test that we actually want to run, which in this case is the project security dashboard spec. I do provide a couple of command line parameters which I find useful. QA debug true, which does give us a bit more information on what the test is doing, which can be useful for debugging a test or building out a test. And Chrome headless, which it defaults to true, so by default the browser is running in the background. Chrome headless false actually allows us to see what is happening on the browser. So as a bit of a demo, I'll execute through the test. So just say a pwd. So I'm in the GitLab directory, I'm in the QA subdirectory. So here's my commands: QA debug true, Chrome headless false, bundle exec bin QA, which is our test executable, the catch-all instance, my instance name, which is a local GDK instance, and the test I want to run, which is the project security dashboard spec. I kick that off. Then does its thing. It logs in. It can be quite eerie watching the browser drive itself, but it's quite cool as well. So it just does a bit of setup, just a bit of overhead things like creating an API token, etc. Yep. Grab a new personal access token, which is fairly boilerplate for our QA end-to-end specs. So you can see we've created the merge request, or visited the merge request, waiting on the pipeline status. We do a bit of a pull, wait for the pipeline to succeed. Pipeline has succeeded. So then the automated test should be ready to merge. We selected the merge button. Visit the pipelines. Wait on the latest pipeline to be successful. This pipeline is successful. So we should go into the submenu. Yep, submenu vulnerability report. And that brings up our vulnerability reports. And we can drill down the details of a particular vulnerability. And it was quite quick, the match in there when the page loaded, so. So then on to the next test, vulnerability report. Yeah, which rolls down into the details, creates an issue, edits the issue. This is a fairly new end-to-end spec that was created based on an issue that was fixed. Okay. So we had 2 tests, 0 failures. So yeah, that's basically running through the end-to-end tests. So that was an example running against a local GDK. We can also run against an environment, for example. If we see issues on staging, we may wish to point the test against the staging environment. So it's just a matter of, instead of this GitLab instance here, instead of the GitLab instance being set to the local GDK instance, you set the GitLab instance to be the staging environment. I won't list the CI variables needed for logging into this environment here. It's confidential. The required variables are listed in this link, the GitLab QA link. There's a lot of great information here. Recheck the quality if you do want to run a test against staging. GitLab QA is a gem which acts quite similar to the bin QA, but it has many more scenarios. For example, if we wanted to run against a nightly image, We can run GitLab QA test instance image EE, and say we wanted to run all of the secure end-to-end tests, we can just specify the secure directory. So running against a merge request, unless changes are made to the QA directory, this requires selecting the package and QA manual action in the test stage of the pipeline. This goes to a bit of a package, builds up the omnibus image with the changes, and kicks off a pipeline for the GitLab QA mirror project. So it gives you the full test coverage. Does take a while to execute, and there may be unrelated failures which can cause the sub-pipeline to fail, but if they're investigated and aren't related to the merge request, then that shouldn't be too much of a concern. I guess the disadvantage is that there is no granularity into the actual area to test, so we may only want to execute secure tests, for example, but we would need to execute the full suite. So when do we run our tests? Ad hoc, anytime, merge request, if we have a package in QA stage. Pipelines, so I will have a future brown bag which will concentrate on the pipelines. This is a good link to show you the full pipeline list, but we have several pipelines. Their cadence are listed here from typically every couple of hours, at least one environment will get executed. Some, such as pre-prod, are executed after deployment to that environment. The quality team just does have a rotation where there will be a DRI, primary and secondary, between two time zones every week, who will review pipeline failures, so they are being constantly monitored. So who runs maintenance tests? Running locally, your local user. If your instance has a different username or password from the usual, then GitLab underscore username and GitLab password would need to be specified. MR pipelines use a GitLab QA bot. In terms of maintaining the tests, so typically the SCT, who is the DRI for that particular stage, can introduce new tests, maintain a test, update. Ideally, if there are changes going into a merge request, particularly on the front end, end-to-end tests could be updated at that point rather than being reactive when perhaps pipelines are affected by any changes. So I'd mentioned earlier that our end-to-end tests, the analyzers have a CI that is effectively a no-op. That is because we are quite UI focused and our tests are executed quite frequently. We are comparing UI elements against expectations rather than actual reports. So what we do have are the secure test projects which do execute the analyzers. These are run nightly by the orchestrator, although there is a future plan to group these by analyzer rather than the current by project. So the secure test projects, they have some, they have some code in an actual project, multiple languages, frameworks, package managers. They bring down the image container, run through the analyzer as they would be run on a customer environment, generate the reports. There is an expectation. Those are compared. So it is a good test of the integration between the projects and the analyzers. The secure test projects and the secure test orchestrator do find defects within the analyzers. For example, there was a recent issue with License Finder where a .NET third-party plugin had an issue where it was trying to run a curl command to bring down an install script. This suddenly redirected, was bringing down an empty script. It wasn't installed on .NET, so .NET wasn't building, License Finder wasn't finding any licenses. The expectation then failed against what was generated and what we expected. So, I am confident that these two different levels of tests do find issues at different levels. So in conclusion, our end-to-end tests are testing particular workflows. They're living under the QA specs directory, mostly UI driven, so if there are UI changes, front-end changes that can affect the tests, that's not to say that back-end changes don't affect things. There was an issue recently where there was a delay between the pipeline being run and the DB being populated and this being reported back to the dashboard, which led to us loading up the dashboard before the data was available, which failed the test. So, the test can be affected by both front end and back ends. We execute against an omnibus instance or an environment, pipelines, locally or in an MR. The pipelines do have a regular cadence. They report back to Slack, and as I say, I'll touch upon debugging the pipelines in a later brown bag. These are typically maintained by the SCT. It is useful to get a bit of a heads up. I do try to keep an eye on a bit of a quad planning process. Try to keep a bit of an eye on what's coming down the pipeline in future. And the last thing we touched upon was that while the end-to-end tests don't run the full analyzer image, these are covered off. We do have good coverage within our secure test project pipelines. Some very useful links here. I won't go into them individually, but if you pick up the slide deck, there's a lot of great information here. So thank you. I will schedule an AMA so that any questions you have, I know I've kind of rushed through things here, but yeah, thank you very much.